Welcome back to Young Tutor. Today we'll be starting with exponents. So, we will be starting up with exponents, which means that first let's understand what are exponents. Exponents are nothing. Exponents are nothing but the numbers, any number that has been set to a certain power. Now, what is a power? To understand what a power could be, first let's understand with what is how can we multiply multiplication. So let's understand simpler with an example. So to consider a number, to give an exponent to a number, we can take the example of writing it as 7 times 7. So we can see that this is an example we have taken. We can see that there two numbers are the same numbers which are being multiplied with each other. So we can also write this as 7 squared. Now this is what powers are. Now let's of course then all we have to do to figure out easy way of finding a power is just remove all the similar numbers or the same numbers and put the how many of those numbers are there in the equation, just put that on the top. Okay, so practically speaking, if we say like any two numbers are being multiplied and then we are dividing it with the same number, so you can see that there's a division symbol coming in the middle and we're dividing it with the same number. Now if we take it to powers or exponents level, this is equal, as we see, if you remember, the minus of minus will if there are even number of minuses, we can just eliminate the minuses or discard the minuses. But in this case we will not do that, as we can just write minus 2 whole square by minus 2. Minus 2 whole squared by minus 2. So we can see that here there's the division of the two numbers are coming. Another thing that we can learn here is that all we are doing here is, like, any base number has an exponent of 1, which means all we are doing is adding the number, adding the exponents and putting the number right here. That is the addition or the total of all the exponents, which means what, that is during multiplication. So what can we do during division? During division, all we have to do is subtract. So as we know that here the power is of 1, a whole power of 1. So if the whole power is of 1 and this thing's that is minus 2's whole power is 2, then we have to do is minus 2 whole to the power 2 minus 1. We can see that we have simplified a division sum into a normal without division, with a number that doesn't use division in its problem. We can again write this as minus 2 to the power 1 or minus 2. I know it's quite lengthy, but most of these steps can be eliminated. That is, we can directly use the method of cancellation over here itself to cancel out these two. But I'm giving an example of how to use powers. Now let's take an example of how to understand cubes or larger numbers. So we can and what are considered squares or square numbers, or cubes or cube numbers. So to consider a number a square or a cube or a power or an exponent, we can write it as so we have understood 7. So we'll take the same example here, 7 square. We can write 7 square as 49, because we remember in the tables that 7 into 7 is equal to 49. We can use the same method for any number, as multiplying the same number by itself is nothing but squaring. We can also use the method, we can also write cubing. So how to cube a number is nothing but taking 7 times 7 times 7. So we can see that all the powers are of 1. Therefore, all we are doing is writing the same power exponent. It's the same thing, just adding another multiplication and another 7, or practically the same base number. So what is 7 cube equal to? 7 cube is equal to 7 into 49. We know that because 7 square is 49. So 7 into 49. quickly do the math and check the answer. 7 into 49 is 343. Now let's understand how can we use rational numbers and exponents and combine them together. So let's take the example of 2 by 3 whole to the power 4. Big exponent, but fine, it's as the numbers are small, it's okay. We can write this number is equal to of course, remember that whenever there is this the parentheses and after the parentheses there's a power, it means that both of these have an individual power of 4, which means we can write this equation as 2 to the power 4 by 3 to the power 4. Remember that this is only applicable when there are the brackets in the question itself. Now let's move over to how to solve this. We have learned on how to divide this, but how can we divide a whole rational number? We can do it in this form. So we can write 2 by 3. So if you remember, this is equal to this. So remember that, keep in mind that don't try to divide the rational number or divide the exponent equally. Instead, try to use this itself. So we can write this equation as 2 by 3 into 2 by 3 into 2 by 3 into 2 by 3 into 2 by 3. So we can see that as the power or exponent is 4, we are multiplying by the same number 4 times. This is also equal to, we can see that we can write this in another format. We can write this as, we can also group this number. As the exponent is huge or the number is huge, all we can do is grouping the numbers. All we can do is grouping the numbers. By grouping these two numbers, we get two different pairs. And this is easier to solve as they're just squares of the number. So we know that 2 square is 4 and 3 square is 9 into 2 square is 4 and 3 square is 9. So we can see that it's simpler as we know the squares. That's why remembering the squares are more important. 4 into 4 and 9 into 9, they both are equal to 16 and 81 respectively. So we can see that this very complicated equation actually has a very non-complex answer. Now let's take for an example, let's take the mass of the earth. The number is very big, as I will be saying right now. It is 6 septillion, and we know that the 6 septillion is a very big number. So we can see that this number is in kilograms, that is in kg format, which means this is a very large number, very large. So now how can we write this in a simpler way? So first thing we'll do is count how many zeros are there in this whole thing. Let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There are 24 zeros in this whole equation or expression or number practically. So we can write this as, we'll take only the 6 and leave the rest of the zeros. Then we'll put the multiplication sign write 10 to the power how many ever zeros are there. So in this case there are 24 zeros. So you can see that this big number has shortened down into this small of an equation. Because by just multiplying by 10 to any number, you can increase or add a 0 to the number. Therefore this formula, all it does is that we are doing 10 to the power 24 and then multiplying, that is 1 septillion, because 10 to the power 24 is equal to 1 septillion. So by taking 1 septillion we can write it as 6. So and then multiply 1 septillion by 6 to get 6 septillion. So the value, even though the size changed, the value does not change. Now let's take the opposite side. So we've taken a large number. Now let's take a very small number. That is a number that comes into the that is above 0 but under 1. So let's take the example 0.000000813. So you can see that the number, we can see that the number is very small, but this number is still relatively huge in the size or in its space occupied. So we can write this number as, all we are doing is moving the decimal this direction, and for every decimal that we move, we will add a negative exponent and multiply the exponent will be on 10. So we will be multiplying 10 to the power the negative exponent, that's negative x, into 8.13. So we have to come over 8. So we get 1 jump, 2 jump, 3 jumps, 4 jumps, 5 jumps and 6 jumps. So we can see that we get 6 jumps. You can see that we get 6 jumps till 8. So that the decimal point will be between 8 and 1. So we can write this number as 8.13 into 10 to the power minus 6. Why? Because whenever you apply a negative, exponent to 10, the number goes that is the point, or the decimal point goes in a backward direction. Therefore you'll add more decimal points and increase the number of zeros. So for today's homework, as the session has ended, if you watched this far, thank you for watching. And now let's just before you leave, let's get started with our homework session. So for the homework for everyone, let's take some basic exponential numbers which you can write in the form write as an answer. So we'll take 3/4 whole cube. So I've taught you how to do this. You can do it on your own. It's very simple. Go ahead and try it. For the second one, we'll be taking 11 square. That's nothing but 11 into 11. For the third one, I want you to simplify this number. Simplify the number Okay, so simplify this number 370,000 kilometers. So remember to not change the unit. The answer should be in kilometers itself. And I also want you to simplify the number or the speed of light. This is just under this, but we'll take it in a different unit, that is in liters. Okay, so this is your major homework, but some sub homework that I'll also be giving, that is just the last homework for everyone. will be to just try and solve this, because I'll be covering this same topic next time with more detailed explanation. But all I want everyone to do is just try to solve it and give me the answer next time in the comments below for these questions. The question is a cube into a to the power 4. This so it might be a little tough as I've not taught this, but you can go ahead and try it on your own. Thank you for watching. Comment the answers down below and subscribe to the channel if you like the content. Thank you. That's it. Thank you for watching.